This is a picture of a computer hard drive. It's about the size of an 8-track tape, if you know what that is. Think of the hard drive as a large warehouse where the computer programs are stored. This is a picture of a RAM memory module. It plugs into the inside of your computer. This is a picture of a CPU, a central processing unit. This is the item that does most of the important work in the computer. When you click your mouse to open a program, it used to be that the CPU sent a message to the hard drive saying, send out this particular program. Well, it was all right, but it was a very slow process. So somebody invented an intermediate step called random access memory, RAM. Now, when the CPU sends a message to the hard drive to send out a program, it is brought into the RAM module as a staging place. So it increases the speed very greatly because the CPU doesn't have to wait for the hard drive to find all of the information, gather it, and send it out. It is brought out, stored in the RAM, and it's immediately available for the CPU when requested. So a quick summary of the process is that the hard drive sends the program information to the RAM, and it is held there as a staging area to be used by the CPU. When all is going well, it goes something like this. Let's say, for example, the RAM is 256 megabytes. The program being requested from the hard drive is 200 megabytes. So the hard drive sends it to the RAM holds on to it until the CPU needs it, and everything goes very smoothly. But here's an example of when things do not go smoothly. The RAM is 256 megabytes in size, and the program being requested is 600 megabytes in size. The RAM room isn't big enough to house the program that is being requested. Because the RAM doesn't have enough room for the program, it creates virtual memory on the hard drive, or another name for it is a swap file. When the information goes into RAM because there's not enough room, the RAM sends some information back to the hard drive and takes up a portion of the hard drive for storage. When the CPU asks for information, if it's not immediately available in the RAM, then the RAM accesses the information from the hard drive and brings it back into RAM. But when it does that, because there's not enough room, it has to send something out, and then the information is sent on to the CPU. So instead of being a straight-through sequence of information, it is a sequence that goes from RAM to swap file to RAM to CPU, and it's happening continually, so the computer slows way down. One very obvious question is, well, how much RAM do I have on my computer? And here's how you check. We're doing this in Windows XP, but Vista is very similar. Click Start, and then choose Control Panel, and in the Control Panel go to System, Systems folder, and open it. And at the bottom of the General tab, you have the amount of RAM that is installed on your computer. In Windows XP, here's how to check the demands that the computer is making for operating space and the amount of RAM you have to accommodate that demand. On your keyboard, at the same time, press down 3 keys: Control, Alt, and Delete. Control, Alt, Delete. and it brings up the Windows Task Manager. And at the top there are a number of tabs, and if you'll click on Processes, just out of curiosity, you have a list of processes that are running in the background on your computer. And there will be 30, 40, 50 of those that are running that you had no idea are in progress. But they are running, and they are taking up operating space on your computer. Pick the next tab over is Performance, and we get a screen that looks something like this. And the two areas in which we are interested particularly are down here at the bottom. One is a physical memory, and the total will give you the amount of usable random access memory, RAM, that's on your computer. The other number we want to look at is down here in the left corner, and it's called the commit charge. The total will indicate how much space is being used by the computer while it's sitting still at the moment. We want to look at the relationship between the commit charge and the physical memory. If the commit charge is more than the physical memory, then the computer is having to set up a swap file to deal with the lack of space, the lack of RAM available to process the information. So the better ratio would be when the commit charge is much less than the physical memory. But if that commit charge exceeds the physical memory, then the computer is running slower than optimal, just as a matter of course. There are a number of things you can do to increase the performance of the computer, but for most computers, the single most important factor is the amount of RAM that is installed. If you want to increase the speed of the computer, there are two factors to take into consideration. One, increase the amount of RAM installed on the computer, and the other, to decrease the number of programs that are running in the background. We're the Computer Doctors in Jacksonville, Illinois. Thanks for watching.